What is a short? So you're going to hear a lot of people say, oh, there must be a short. Oh, the reason the circuit is not working is because of a short. And it's just something that like people hear on TV when they're 6 or 8 years old, and they just start using that word as an explanation for every single problem because they don't actually know what's going on. So let's try to explain an example of a short, what a short is and what a short can do. So let's get a schematic going on here, and I'll try to show you what a short circuit is here. Now, a short circuit simply means that instead of the power going where it's supposed to go, it gets stopped short, it gets stopped before it gets where it wants to go. So for example, this is a circuit for the charger, turning the charger voltage into 12.6 volts for the system to run off of in a Retina MacBook Pro. So you start up here, the charger goes through here, and then it goes through here. These two transistors create pulses, and then the power goes to the system, right? Now, a short can be anywhere in the circuit where it's stopping the power short. So, for example, let's say one of these transistors here, let's say this one over here, instead of being opening and closing when this chip tells it to, let's say this is shorted, it's shorted to ground. Let's say this chip has a 0 ohm resistance to ground at all times. So instead of this power making its way all the way over here, right over here it gets stopped short because over here it has a 0 ohm resistance to ground because this transistor decided to die. See over here, this thing over here represents ground where you see those 3 lines over there. And this is going to stop the power from making it over here. It's never going to make it over here because there is 0 resistance to ground, 0 ohm resistance to ground on this transistor. So a short is pretty much anywhere in the circuit where the power itself stops. It's stopping it, and it's keeping it from going where it's supposed to go. And most of the time that is occurring because of a short to ground. So you could have a short over here where, let's say, this transistor simply died, so it's not even shorted to ground, it's just not opening. That could be a short. Let's say this resistor is blown. That could be considered a short, so the power is stopping short over here before it makes it all the way where it's supposed to. You could have a short to ground over here. That's what it means when somebody says a short or a short to ground. They simply mean that the power has stopped from going where it's supposed to go. Now, what I just talked about is how a capacitor works in a circuit to create DC from pulses or from alternating current. A capacitor has to be attached to ground on one end so that the power will stick on the other end. Again, the electricity, think of it like we're manipulating the electricity. The electricity is not simply going to stick on one end of the capacitor and get charged there without thinking that if it just stays there long enough that it'll be able to cross over to that insulator to the other side. The electricity it wants to go to ground. You need to give it what it wants. You need to at least give it the illusion that if it tries really hard that it's going to get what it wants. So capacitors are always attached to ground on one end. Now, a very common problem is the capacitor dies, or that insulator blows, or it gets destroyed, and now the capacitor is shorted to ground. So the signal is shorting to ground through the capacitor. So here we have a capacitor, right? So we have a capacitor. We have two. Let's just zoom in on this so you can see what I'm talking about. So this is the main 12-volt rail, and over here is the capacitor going to ground. This is a capacitor going to ground. So here's one plate. On the other side, there's going to be an insulator in between over here, like I explained in the previous capacitor video. And this over here is another plate that's going to ground. Let's say that insulator blows or gets destroyed, and these two plates are now touching. This power, now, this is not going to be blocking DC anymore. It's going to be allowing anything to go through. So all of this power, this 8 amps, not 8 amps, but the 5 amps or whatever that is going here at 12.5 volts is all going to be going to ground, and that is going to kill the circuit to high hell. So that is how a capacitor very often, very commonly, shorts to ground and causes the circuit to be what's considered shorted. That is what a short circuit actually is. Again, most people, they say if it's not working, there's a short, but they don't even know what the terminology is. They don't know what a short circuit is. They don't understand where this came from, and that's one of the important things to understand if you're getting involved in basic electronics, because most of the time you are going to be chasing short circuits to ground. Another thing that can happen here. Again, a transistor can short to ground. I'm going to talk about that in another video about what a transistor does and the fact that a transistor is just a resistor whose value can change. A resistor can very easily come open as well. So right over here, Let's see over here you have charger voltage. So this is charger voltage going through these two resistors. One resistor is going to ground, the other resistor is going to ACN over here. That's called a voltage divider. I'm going to explain what a voltage divider is in a new video, so don't worry if you don't know what it is here. The whole point here is, you see how this resistor is 40 kilo ohms to ground? What if this resistor opens, and what if this resistor shorts, and now instead of being 40 kilo ohms, it's 0 ohms? What it would do is it would send the entirety of this to ground. So let's say this 130 kilo ohm and this 40 kilo ohm resistor both became 0 ohms because they got wet, or because of a power surge, or because they got, somebody hit it or punctured it. Now this would send the power all the way to ground. So any one of these components, when they malfunction, can start to function like a wire. So you have all these components that are going to ground and taking voltages and taking them to ground for different reasons to accomplish different things, but you don't want it to be like a wire going to ground. Once that component starts behaving like a wire, once any of these components that go to ground starts behaving like a wire, it can completely destroy and wreak havoc on the entire circuit, and that is what we call short-circuited to ground.